Hey guys, in this video we're going to be talking about the quadratic formula. The quadratic formula is just one of the ways that we have in order to solve a quadratic equation. But unlike factoring, graphing, using the square root property, or completing the square, the quadratic formula will work for us in every single situation. So it's an important formula to have in your tool belt. When we're using the quadratic formula, this can be a lengthy formula to memorize. So we have a special song that helps us memorize the quadratic formula. It's sung in the tune of Pop Goes the Weasel. I encourage you to sing it with me. Here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And there we have it. Now, I know this sounds silly, but even after all of these years, I still have the quadratic formula memorized because of this song. Now, the steps for using the quadratic formula are as follows. We're going to make sure that our quadratic equation is in standard form so that we can identify the values for a, b, and c and substitute them into our quadratic formula. Then we're going to simplify underneath the radical, separate our formula into two equations, simplify the numerator and divide, and then make sure that our solution is written in set notation. That would be in braces. Now note, if a, b, and c are fractions when we're looking at the quadratic equation, we want to multiply everything by the LCM so that we can get rid of that and plug those values into our quadratic formula. Let's get started with this first example. Here we have x squared plus 7x plus 6 is equal to 4. So we're going to identify a, b, and c, which in this case are 1, 7, and 6. Then we're going to substitute those values into our quadratic formula. So for negative b, we're going to have negative 7 plus or minus the square root of 7 squared minus 4 times 1 times 6 all over 2 times 1. Now let's simplify underneath the radical. So we have negative 7 plus or minus the square root of 7 squared, which is 49, minus 4 times 1 times 6, which is minus 24, all over 2. We simplify that further, we get negative 7 plus or minus the square root of 25 over 2, and then let's go ahead and separate this into two equations. We do know that the square root of 25 is 5, so when I'm separating it, we're going to write 5 instead of 25. So we have 7 plus 5 over 2, and we have negative 7 minus 5 over 2. And then let's simplify. We know that negative 7 plus 5 is negative 2 over 2, which is negative 1, and we know that negative 7 minus 5 is negative 12 over 2, which is negative 6. So we know our solution here is negative 6 and negative 1. Let's look at the next example. Here we have a is equal to 3, b is equal to 5, and c is equal to 11. Now let's substitute these values into our quadratic formula. Negative b will be negative 5 plus or minus the square root of 5 squared minus 4 times 3 times 11 all over 2 times 3. When we simplify underneath the radical, we get 25 minus 132 all over 6. Now, when we subtract 25 and 132, we have negative 107. Now, we know that we cannot have a negative underneath the radical sign, and based off of our lesson from the discriminant in the previous video, we know that this problem will have no solution. So we'll write it as no solution. Let's look at the third example. Here we have one that has fractions. So we're going to begin by multiplying everything by the LCM, the lowest common multiple in the denominators. So we look at 5 and 25, and we know their smallest multiple that they share is 25. So we're going to multiply the entire equation by 25. 25 times w squared is just going to be 25w squared. 25 times 2 over 25, well, the 25 in the denominator will cancel out with the 25 that we're multiplying by, leaving us with just 2. And then when we look at the last part, we have 3 over 5w times 25. We know that the 5 will cancel out with the 25 that we're multiplying by, and so then we would just have 5 times 3, which would give me 15w. Now let's get everything on the same side so that we're in standard form. Here we would have 25w squared minus 15w plus 2 is equal to 0. Now let's identify the values for a, b, and c. A would be 25, b would be negative 15, and c would be 2. Now we can substitute these values into our quadratic formula. So x would be equal to negative b, so negative of negative 15 plus or minus the square root of negative 15 squared minus 4 times a, which is 25, times c, which is 2, and all of that is going to be over 2 times a, which is 25. Now let's simplify. We have x is equal to, well, the negative of negative 15 is positive 15, plus or minus the square root of 225, that's negative 15 squared, minus 200, that's what we get when we multiply 4 times 25 times 2, all over 50. Simplify further, this gives us x is equal to 15 plus or minus the square root of 25 over 50. Now we know the square root of 25 is 5, so when we're splitting up our two equations, let's make sure that we write 5 and not the square root of 25. So we have 15 plus 5 over 50, and we have 15 minus 5 over 50. When we simplify, this is going to give us 20 over 50, which simplifies to 2/5, and here we get 10 over 50, which simplifies to 1/5, so in our solution in our set would be 1/5 and 2/5. Let's look at our last example. Here we have y squared minus 4y equals 4. We're going to begin by subtracting 4 on both sides so that we can get this equation in standard form. Once we do that, we have y squared minus 4y is minus 4 is equal to 0, and we can now identify a, b, and c. A in this case would be 1, b would be negative 4, and c would be negative 4. Now let's substitute these values into our quadratic formula. For negative b, since we're putting in a negative 4, it's really just going to be positive 4, plus or minus the square root of negative 4 squared minus 4 times 1 times negative 4, all over 2 times a, which is 1. Now let's simplify. So on the outside I have 4 plus or minus the square root, well, negative 4 squared is 16, minus 4 times negative 1, or negative 4 times 1 times negative 4 gives us positive 16, so plus 16 over 2. Well, we know that 16 plus 16 is 32, and so we have 4 plus or minus the square root of 32 over 2. Now the square root of 32 is not a perfect square, but I know that I could break negative 32 up into 16 times 2, so it could be simplified to 4 plus or minus 4 square roots of 2 over 2. Now we can simplify this. We can divide both 4 and 4 square roots of 2 by 2, so this would simplify down to 2 plus or minus 2 square roots of 2. Now we can only divide the numerator if both items are divisible by 2. So in this case they are, so we get 2 plus or minus 2 square roots of 2. This would be our simplified radical form. However, if we wanted to round this, we would need to go ahead and approximate 2 square roots of 2, which in this case would be 2.8. And so when I'm breaking up my two equations, I would have 2 plus 2.8, or I would have 2 minus 2.8. And so when I'm solving here, my solutions would be 4.8 and negative 0.8. And so in my solution set, my solutions would be negative 0.8 and 4.8. Now remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is how we solve quadratic equations using the quadratic formula.